The first one is, for me, is critical to understand how, what is in the basement of any kind of interdisciplinary research in a way in which we are understanding that. The second one will be complexity, and I will just show three main approaches to complexity. There's no only one or two, at least are three of them. The third point will be one of these three is the genetic epistemology and theory of complex systems that my professor and colleague in Mexico, first in Geneva and then in Mexico, Rolando Garcia Butig, has developed as a way of making methodological sense of the interdisciplinary objects or problems to study. The fourth point will be also the complex system theory, just some words about that and the way in which is located in the core as epistemological foundation of interdisciplinary research. And the five one, just open questions and talk. How, when, with whom, for whom we do research. And that's it. So I begin with, first time, dealing with critical problems. For us in Mexico, in a society as Mexican society, we have an amazing amount of critical problems, not only just linked to our border with the United States, and especially now with this orientation of President Trump against everybody in the world. First of all, we are the first in line, and dealing with critical problems. That we are facing problems of poverty, problems of migration, problems of obesity, problems of violence, of drug cartels, and so on. It's a very critical problems. So my university, UNAM, Universidad Nacional Autónoma de México, is a public university. It's paid by all the taxes, all the people. In my understanding, we have to do and we have to deal with this kind of problems in order to give some light or lights in the middle of this. So, a critical problem for us is a kind of problem, a situation in the world that we do not want to pay its consequences. We don't want it to continue. We want to help to stop it or to deal with, to cope and try to overcome that after a number of not only economical, political, ideological, ecological consequences. Because it has a lot of high costs, risks, injustices, and so on. And the knowledge you have to understand it is not enough. We are really sure it's not enough. The way in which we are collecting and storing knowledge and diffusing knowledge is not enough to cope with it, confront them. And for instance, that was just 2 months ago, labeled as global syndemics for the Lancet review, the Lancet journal, is a joint complex between climate disaster. I refuse to name it climate change. It's a climate disaster. Plus undernutrition and obesity. Mexico now has is contesting United States in the number of children with obesity. United States the first one, Mexico is following. Just sorry. But that thing was not happening 40 years ago. Something has changed, and we could make some ideas. Every discipline is telling something about that. But the problem is much more than than just one thing or two things. And under nutrition, it's just eating, and not only a problem of just food security, but also we're facing problems of food sovereignty. We are not deciding what kind of seeds, we are not deciding what kind of technological packages, what kind of food processing we decide to eat, to go with a healthy society, and now we're paying those costs. And for the state, Mexican state are paying an amazing, massive, mammoth amount of money just to the treatment of diabetes. And it's increasing more and more and more and more and more. So for me, for us, normal, I said normal as in a Thomas Kuhn sense, normal disciplines just do not know how to deal with it. And its consequences are still hurting, are still eroding society and social life. And it seems to be everything, all of them is connected, but we don't know how and when, from when. And disciplinary knowledge cannot afford this. But why? Why the disciplinary knowledge cannot afford with this? Because of three things. Because of the domain of any discipline. If any discipline in the world is existing, it's because it has defined a domain of phenomena. And for that domain, the theoretical assumptions, the concepts for dealing with that domain has been special designed to deal with that domain of problems. And that domain helped to raise specific kind of questions that according to that domain. And of course, those questions and that domain just tends to create and cut especially differentiated objects of study. So this is not a failure. It's not the defeat of the disciplines. No, not at all. But the kind of problems that every day are raising and just threatening the whole world society, and of course Mexican society, Latin American society, are just beyond the domain, the question of the object of any single discipline. And the temptation is just to join them. And for instance, the problem of water. Water is a big global world problem. And when Monica and my team, we are doing research in the desert of central Mexico, it's a problem not having water for rains for 14, 13 months. And the peasants, the shepherds, the miners living there, they think that their problem but it's not. It's linked to the problem in Brazil and to the problem in the Sahara, in the problem in the Sahel. They don't know, and only trying to cope with this kind of problem, locate the kind of problem, won't be exactly the tool, won't give us the tools to understand and to cope and to confront the problem. So, enter into the second part. Complexity, three main approaches. The complexity paradigm was named like that for Edgar Morin. Edgar Morin, he is still alive, but he was a sociologist in the beginning. And in the 80s, he all of a sudden have an insight and make some change from his trajectory and began to write and to write about criticizing the old sciences that of modernity, the modern science, and he called the simplicity paradigm. Opposing to that, the complexity paradigm. Because complexity paradigm should be understood as a multidimensionality, multi-temporality, non-linearity, opposed to simplicity paradigm. It's only the unidimensional, mono or atemporality and linearity that modern disciplines follow a Newtonian style of understanding science. And I think it's not a theory in scientific terms, but it's a way of thinking. It's a kind of philosophy that I could accept. I can accept that. I can go forward for that because it has to do with education, with the ecosystems, with all the things, the different temporalities, dialogue, interculturalities, and not exactly a scientific theory. So it's very useful to move to make conscience about this, but it's not where my center is playing in the game, in a league in which we have to produce science. And it's okay to say sexy or attractive concepts, but we were talking how to deal with that. So this is the first one, just a simple approach. Second approach, the sciences of complexity, so-called the sciences of complexity, that are pretty well represented by Santa Fe Institute, Complex System Society, I am part of that, the New England Complex System Institute, and the Complexity Digest is a network of every week we receive a whole bunch of articles dealing with complexity, with some of these issues. And these sciences of complexity, the leaders are people trained in computer, in mathematics and physics. It's like a part of the real existed sciences, nature sciences and others, biology also, that coming from their domain are trying, using computer power to processing and mathematical algorithms to modeling problems using those tools, but they are really honest and they recognize they don't have still a theory. I consider, I work all of them, with a lot of them, a kind of technological or computer empiricism. Empiricism in which has to do with assuming that knowledge coming enter through the senses. It's dealing with senses. And the third approach, Rolando Garcia, who worked intensively with Jean Piaget, the creation of that Piaget called genetic epistemology, has elaborated a very interesting, not published in English, but in Spanish, the theory of complex systems. That is both scientific support for interdisciplinary research and very also powerful tool for methodological frameworks for empirical studies on this kind of problems. This theory was not just invented by Rolando Garcia. The theory came after 20 years of reflections, 15 years of reflections about the big problem that Rolando Garcia, as the head of the United Nations Office for the Study of Global Circulation of Atmosphere, he was a meteorologist, cope with the famine is correct, the famine that happened in the world, but especially in the Sahel, in just the south of the Sahara desert. And then came to Mexico, still there in Mexico. I have the opportunity, the luck to have, I was telling yesterday that thing, that to be oriented as a theoretical advisor Alberto Cerese, and methodologically Rolando Garcia in my PhD degree in Mexico. So that is, let's enter a little bit to the core of this thing. Just closing. These three perspectives share some words, some concepts in common: self-organizing systems, resilience, emergence, positive and negative feedback loops, self-reference, criticality, and some others. But their outcomes are pretty quite different. So the theory of complex systems provides both, I said that, a powerful methodological framework and the foundations for interdisciplinary research. To understand that and its scientific power, we need to understand the direct relationship between complex system theory, that specific edition of complex system theory, and genetic epistemology, also called by Piaget constructivist, or simply scientific, because in practice, the three adjectives, constructivist, scientific, or genetic, make up practically a pleonasm, are almost identical. And the key for understanding that is the study of how the knowledge structures of human being and human institutions devoted to knowledge come from the registering characteristics or properties to the establishment of relationships or states, and from these states and structures to from structures to processes of transformations. This is very abstract, but I think we could talk a little bit more about that. So that would be the place to locate Rolando Garcia's complex system theory. Let's have a snapshot from knowledge of critical process. I also stated yesterday, to create a multidisciplinary team to face a complex problem, a complex critical problem, this team has to be in accord, has to acknowledge and has to discuss and share an epistemic framework. That means they have to take position against or from or for in front of the problem, and sharing this point of view, this Weltanschauung or Problemschauung, to see that they can share these values. This is this framework is a tool for studying the history of sciences that Rolando Garcia used studying the story of a lot of disciplines. And from this epistemic framework is the nest, is the beginning, the principle in which creates our questions for research. And they have to create, this team, multidisciplinary team, has to create two. The second one is the conceptual framework. It's not just an issue to put aside concepts because they are sexy or attractive or they are pretty good, influencers, blah, blah, but to create and to translate and to create a special framework to deal with that problem. And at the end, to create a methodological framework. So these three products, outcomes, should be the task of a multidisciplinary team. And this is not easy. I'm telling you because I'm working in the center. We are 100 researchers, 100 researchers, and it's not easy to dialogue and because everyone has their own right of, no, these are my concept, this is my domain, I can collaborate with that, but it's not enough. We need to transgress borders of these lines. And it's not easy to abandon or to be and in non-equilibrium momentum to do that. And also implies a lot of communication between the colleagues. And in the normal time, these actual times, that kind of collaboration is very difficult because the systems for evaluating all over the world in the academic field and scientific field are mainly individual. I, me, my, I publish in the journal, and this is very, very complicated to do that. It's a kind of real problem, not just to know the theory, but to actually have a group of people interested and taking the position against the problem to create, in collaboration, of creating a special conceptual framework, and also to create this kind of procedural methodological framework. If not, it's just, again, mind games just dealing with the things. So for instance, in order to cope with the complex object, it's a kind of triangle. We need a complex object of study, a collective team, multidisciplinary one, and a complex system model. One myth, collective team, that one. Is not, as I had said that before, it's not only a way just to get together and take some engineer in water, take some other, anthropologist, blah, blah, but they cannot talk in between. They don't use the same concept. They think that they are different, qualitatively and quantitatively different to the others. I have also in my center have seen this kind, and I mean, and my work also, a big part of my work now in Mexico is working with multidisciplinary teams of researchers all over the country, trying to facilitate them to talk. But it's very difficult. They say that, for instance, the people from humanities or from social sciences, you are like a poet. You need, it's like literature, like this is philosophy. This is philosophy. I'm doing science, and it's not the case. Probably you have a lot of experience about that. So a collective team is like wishful thinking if we are not facing the way in which we need. Also, I'm coming from the students too. We are training students in this one-track-minded, me, mine, my student, my data, my thesis, my blah, blah, blah. It's very difficult. And the genetic epistemology gives us the tool to talk and to talk and dialogue with really good basis. And I should say that this experience is dealing with biochemicals, with chemist professionals, with physicists, with economists, and so on. They can get together and talk if they could have at least that kind of tools. So this is part of my work. And of course, trying to design a complex system model. I mean, a model, and not only in the way of computer model, but a way of, this is the study we have done, and the relationship we have explicited is connected with is happening in the real world. So if we know the way, I want to finish with that, we know the way in which the things were and elements were getting together, we can confront them with less, or a little bit more of degree of success probably we have. So, organizing and creating, defining a complex system object is connected with organizing a collective team and to create this complex system model to confront with empirical processes. So, it's an example. This is the way in which knowledge as a human specific, in this case, property is understood as action over, into, and within the world. Knowing is acting in the world. And if we're acting in the world, knowing has to do specific with the reorganization and recreation of neural networks, neural biological networks. Also has to do, if we change that, at the same time, we are changing our behavior, our way of acting in the world. Has to do with cognitive networks. And if we're doing that at the same time, not before, we're modifying social networks. I'm not talking about internet, Facebook, or Twitter, or something. It's our place in society and the way in which are linked with others. And that implies studying knowledge as a complex system has to do with biology, with psychology, and sociology. But who will be the king, the queen discipline? It's not, that will be the impronta that the institution, no, you have to be the best, the chief. Because the problems are not packed to be identified by the chief, but this of this thing. So this is a kind of example. Rolando Garcia produced an amazing book called El conocimiento en construcción, la conoscenza in costruzione, that deals with that thing. It's coming from the basements of Piaget to the theory of complex systems. And it fits perfect. It fits very well. Piaget didn't do that. It's Rolando who did that. So that kind of red arrows, that will be I think my last point after that, are very critical to identify because they are a kind of special kind of relationships that we will see in a minute. So it is a slide of, this is the problem that needs a complex system approach because it has a kind of a number of heterogeneous components. They have intense interactions, these components, and are acting in different levels of organization. At the same time, they create a common behavior. They're not isolated. Their interaction creates a common identifiable behavior, if behavior could be like a complex system, and are links, a lot of links. And of course, self-organized. Once the things are running, the beginning of self-organizing processes is amazing. And this is the key word, inter-definability. It's a tricky word because it's not common. It came from logics. Rolando Garcia introduced that to name the way in which this kind of relationships makes you impossible to isolate, to separate the components of a problem. And that has an amazing amount of implications doing research. Because, I'm just going to finish this scheme, of course, every single system, complex system, has a degree of resilience to cope with perturbation coming from outside the system and balancing with vulnerability. Resilience and vulnerability are always like my Brazilian colleague says, jogo de cintura. Jogo de cintura, play of to move and to adapt these things. And inter-definability is a kind of relationship in which you are not, the description, any single science, I yesterday talked about a little bit about that, every discipline, if it is a scientific discipline, has to make descriptions. It's not just series de razón, esseri di ragioni, Aristotle, but it has to do with things, with objects, and they have to describe that. we describe properties of the things, like water. Water. I'm going to a little bit into water to cook. Water has a special kind of properties that everyone knows. It's liquid sometimes. It is transparent. It has no flavor. Has no odor. I mean, of that, it helps to lower thirst and prevents drought. And these properties are related or must be understood when we establish relationships that these elements has in common. Then I'm going to use the properties of water that we link that, I could say that depends of a very interesting structure. It's 2 atoms of hydrogen and 1 atom of oxygen. This structure, this kind of relationships are behind, they are not observed, they have to be inferred, behind these properties of the water. If we change the structure, for instance, adding another one, we have, I don't know how to say in Italian, it's agua oxigenada, peróxido. Very similar to water, shares some of the properties, but you cannot drink peróxido, because it's has a double power of oxygenation. And this is made from physics and chemistry, but it's the same thing applying that. So the relations of interdefinability said that you cannot separate that. And the research, the methodological design, has to do not only with counting or just having evidence from outside, but to follow, trying to identify what kind of this kind of relationship were established. And when you break that kind of relationships is a mess, because the vulnerability of the system, of the system grows a lot. That was the explanation of that, the drought and the thousands of deaths and casualties in the Sahel. It was not the climate, was not the weather, was not nature. So Rolando Garcia published 3 books in Pergamon Press titled Man and Drought. The first title is called Nature Pleads Not Guilty. The second one is The Nature of Catastrophe, and the third one is the roots of catastrophe. And since 1980, in the beginning, at the end of the 70s, Rolando Garcia established that every single catastrophe is not natural, is because the linking with social relationships and geopolitical also determinations, that not only the climate, and so on. So back to the goal of any science, the goal of any discipline is to establish representing processes. Physics, from Aristotle to Newton and Galilei, it lasted 7 centuries from the idea of the movement. And that for Aristotle, there's no movement, because things tends to be still. We need, with Aristotle, to push, an impetus. And when the impetus finished, the things just go back to the state. That conception was the biggest epistemological obstacle to physics and modern science until Galileo, and then especially Newton, break completely that. Because with this kind of, and that kind of knowledge from Aristotle is not saying that he was a fool or something, not at all. But the epistemic framework that he had just gives you some insights in that, and also then a big social power called the Catholic Roman Church with Tommaso d'Aquino. He protected and established that as the. So the reform of Lutero and the other Christian churches not only not stopped science. Galileo was obliged to resign, to retire, and on the other side, in Britain, with the Anglican Church, we have the duty as a scientist to understand, to discover the laws of nature, to glorify the laws of God. So religion in one part was blocking, and the other part was pushing science. And just continuing with this, I said yesterday showed the same slide. I said immediately the properties of this triangle, if you have three angles, three sides, blah blah blah, and with this number of centuries between this and Cartesio, I understood yesterday there's no Descartes, but Cartesio in Italian, Cartesio, Descartes, established that, including algebra into the geometry, and with this structure, same thing like this, anyone can define any possible triangle. And that was in the century of the Cartesio. But at the end of the 19th century, a number, several geometries were assigning that kind of expressions, that structures that tends to create, to explain this object, and you can deduce from this kind of object, geometric object, and this kind of transformation processes, any kind of new or past objects of the geometry. So deductions, and for us, methodology is the procedural implication that derive from the theory of the complex system of Garcia, allow us to design, exercise, and evaluate the generation of observables, not only data, and facts through the use of varied techniques and methods to construct theoretically plausible objectives about concrete problems that have characteristics whose behavior escapes the general domain, I said that again, of disciplines. The genetic epistemology and complex system theory allow us to develop productive and useful methodological frameworks for evaluation and prospecting. So just repeating that, and I quote, the concrete that we have to, the critical problems has to build the synthesis of multiple determinations. Probably you can identify immediately who was the writer, the thinker, the scientist who wrote that. And this, just to apply, is Karl Marx. Nothing to do with Marxism. Marx is the first in history in social sciences that creates a kind of representation that represent processes, not only things or states, structures. And for that thing, Rolando Garcia thinks that Marx was in advance 80 years before Piaget dealing with this thing. And Piaget had nothing to do with Marxism or communism or nothing. He was a biologist who became a psychologist in order to testing empirically his epistemologic framework. So again, just to resume, position taking as askable questions that conform the epistemic framework, the conceptual space, and the methodological one is a search tree. I mean, search tree and conceptual space are concepts coming from artificial intelligence that came from Papert. Papert worked also with Piaget a lot of times, a lot of years there in Geneva. Search tree and conceptual space. So in order to create a good approach to complex problems, we have to create conceptual spaces with very strong bonds, and not only just just placing together, just one side of other. And that's the finish of this. We can questions, opens, or whatever. And thank you very much for this.